Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 1 paper from summer 2023. This paper is worth 120 marks in total, and this is the first video of 6. It will focus on questions 1 to 5, which account for 19 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The method shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 1. The lengths of 3 sides of a triangle are in the ratio 3 to 5 to 7. What fraction of the perimeter is the longest side of the triangle? So if we need to start by writing this ratio as fractions. So the denominator of a fraction is the total number of equal parts. So let's find out how many equal parts we have in total. So 3 plus 5 plus 7, 3 plus 5 plus 7. We have 15 equal parts in total. We want the fraction of the longest side of the triangle. So if we were to write each part of this ratio or each section of this ratio as a fraction, we would have 3 out of 15 to 5 out of 15 to 7 out of 15. Okay, now the longest side is going to have the most number of parts. So the longest side of this triangle is going to be the 7, because 7 is bigger than 3 and 5. So the fraction of the perimeter that is the longest side of this triangle would be 7 out of 15. Part B. The perimeter of this triangle is 60 centimetres. Find the length of each of the 3 sides of the triangle. So we need to share our ratio 3 to 5 to 7 that they gave us at the start. So we're sharing 60 into that ratio 3 to 5 to 7. So we know our total number of parts is 15. We worked that out in part A. Remember, part A sometimes helps us. So we're going to start by doing 60 divided by 15. So that gives us an answer of 4. So one part of this ratio is worth 4. We've got a ratio of 3 to 5 to 7. So we're going to multiply each of those sections of the ratio by 4. So those 3 parts multiplied by 4 is 12. The 5 parts multiplied by 4 is 20. And the 7 parts multiplied by 4 is 28. We have to remember to do it to each part of the ratio. So the length of each side of this triangle is 12 centimetres, 20 centimetres and 28 centimetres. So 12, 20 and 28. Question 2. The bearing of Q from P is 140 degrees. Find the bearing of P from Q. So when we're dealing with bearings, we need to make sure we're working in 3 figures. That one's given in 3 figures, 140, so we're good to go to start off with. I'm going to sketch a little diagram here just to get my head round what it is I'm looking for. So if I was getting the bearing of Q from P, I'd be starting at point P. I would have a north line there because I measure clockwise from north with the bearings, and then 140 degrees. I'm not drawing this completely accurately, guys, but it would definitely be over 90 degrees, wouldn't it? So that would be 140 degrees from P to Q. Okay, so that's what we would have measured for the bearing of Q from P in a clockwise direction. We want to find the bearing of P from Q. So we want the bearing of P from Q. So we would start at Q. So we would need a north line at Q. And then we would measure clockwise from Q to P to get our bearing. So we don't need to use a protractor here, don't worry. But what we are going to use is angle facts. So these 2 north lines here are parallel because north lines will always point north. They will always point in the same direction, and they will never meet. So if we've got these 2 parallel lines here, if we deal with this shape and these 2 angles inside those parallel lines, those are co-interior angles. So 140 degrees plus this angle should add to 180. So 180 subtract 140 is going to leave us with 40 degrees. So that angle there is 40 degrees, which is helpful to us because we want this angle clockwise from that north line all the way around to the line that connects P to Q. Now, angles around a point in a full circle add to 360. So we're going to subtract that 40 degrees from 360, and that will tell us what this bearing that we're looking for is. So 360 subtract 40 is 320. So the bearing of P from Q is 320 degrees. Question 3. The nth term of a sequence is given by 2n add 9. Part A, work out the difference between consecutive terms. So when we're working with the nth term, the difference between consecutive terms, so what we do to get from one term to another, is always indicated by that value in front of the n. Okay, so n is its position in the sequence. So term 1 would be n would be 1, term 2 n would be 2. But the number in front tells you what's happening to get from one term to the next, that term to term rule. So the difference between consecutive terms is going to be 2. So we're going to write our difference is 2. Part B, I. Solve 2n add 9 is less than 99. So this is an inequality. We're going to solve it like we would solve a normal two-step equation, but instead of writing an equal sign, we need to keep that symbol there. So I'm aiming to isolate n. So the first thing I'm going to do is I'm going to subtract 9 because that will eliminate my positive 9 here. So when I subtract 9 from the left-hand side, I eliminate my positive 9. I'm just left with 2n. I need to keep my less than symbol. And then when I subtract 9 from the right-hand side, making sure I balance the equation, 99 subtract 9 is 90. Now remember, when I'm solving, I'm aiming to isolate that variable. So I'm aiming to isolate n. So I want this to be n is less than something. So I need to eliminate the 2 that's in front of the n. Well, 2n is 2 multiplied by n. So the inverse of multiplying by 2 would be to divide by 2. So when I divide the left-hand side by 2, I'm left with n. So I've isolated that variable. When I divide the right-hand side by 2, 90 divided by 2 is 45. This whole thing here is your answer, so make sure that is nice and clear to the examiner because there's no answer line here to put it on separately. It's really important that you keep that inequality symbol there, guys. If you put an equals, you're not going to get the full marks. B, part 2. Write down the number of terms in this sequence that are less than 99. Okay. So the number of terms in this sequence that are less than 99. So again, we're going to use this part here to help us. So we know that when the solution to this equation is less than 99, n has a value that is less than 45. Now remember what I said. N is the term number. So the first term, n would be 1. The second term, n would be 2. The 50th term, n would be 50. So this is saying to get an answer, a solution of less than 99, n has got to be less than 45. So the number of terms that this sequence has that are less than 45 is the whole number that's just before 45, that integer that's just before 45. So 44 terms have a solution of less than 99. Question 4. James has been on holiday to the USA and is flying home to the UK. The price of a gift in a shop at the airport is $65. The price of the same gift online is €60, including delivery. On the day of his flight, the exchange rates were as follows. So 80 pence is equal to $1 and £1 is equal to 1.2 euros. Is it cheaper to buy the gift at the airport or online? So we're going to have to tick one of these boxes. but we need to show how we decide. So I'm not going to tick anything here just on instinct. I'm going to do some working out. So what we need to do here is we need to either convert the dollars to euros to compare it, or convert the euros to dollars and then compare it. So we're comparing the shop in the airport compared to online with delivery included. So I'm going to convert from dollars to pounds to start off with. So I'm going to do myself a little proportion table. So this is dollars and this is pounds. So I know that $1 is 0.8 pounds or 80 pence. Okay, we're working with $65. So I've scaled up here. I've multiplied by 65. So I'm going to do the same to the other side. I'm going to do 65 times 0.8. Okay, so 0.8 times 65. Well, I'm going to multiply that by 10. So I'm doing 8 times 65 because that's just a little bit easier for my brain. So 65 times 8, well, 8 times 5 is 40. 8 times 6 is 48. So that's 520 here. But if I want the answer to 0.8 times by 65, I've got to reverse. I've got to undo that times by 10. So I'm going to divide by 10. So 0.8 times 65 is 52. So that gift is £52 in the airport. Okay? So now what I'm going to do is I'm going to convert that £52 into euros, and then I can compare it with the online option. So I'm going to do myself another little proportion table so I don't get confused using the same one. So here we've got £1. So £1 is equal to 1.2 euros. Okay, we've got £52. So what I've done here is I've scaled up, I've multiplied by 52. So I'm going to do the same on the other side. So 1.2 times 52. Again, I'm going to multiply that by 10 so I don't have to work initially with decimals. So 12 times 52. 2 times 2 is 4. 2 times 1 is 2. Placeholder 0 because I'm moving into the tens column. 5 times 2 is 10. Carry the 1. 5 times 1 is 5. Add the 1 is 6. So that's 624. But I need to reverse the times 10. So I'm going to have to divide by 10. So that's 62.4. So it's 62.4 euros. Remember, this is still at the airport, guys. Okay. So, at the airport, it's 62.4 euros. Online, it's 60 euros, including delivery. We need to know which one is cheaper. Well, that 60 euros is less than 62.4 euros, isn't it? So I can say that it's cheaper online than it is at the airport. Question 5. So we've got a diagram here and it tells us the diagram shows a quadrilateral. So we've got a four-sided shape and then we've got some exterior angles labelled as well. The fact that it's a quadrilateral could be important, so let's pay particular note to that. Use algebra to find the size of the exterior angle y. So we're aiming to find this angle here and they want us to use algebra, which is useful because we've got some algebra there on the diagram, haven't we? We've got some numerical angles, but we've also got some angles that involve the variable x. So this is a quadrilateral. So what do we know about angles inside a quadrilateral? Well, angles in a quadrilateral sum to 360 degrees. So all of these angles here should add to 360 degrees. So I'm going to start by forming an equation for the sum of those angles because that's something I can work with. So we have 60 degrees plus x plus 75 degrees plus 85 degrees plus x plus 70 degrees, and they should all equal 360 degrees. So I'm just going to simplify this a little bit more. So we don't need those brackets. Those brackets are just to safeguard us if we have some negative values or variables in there. So if they're confusing to you, at this point we don't need them. So we're going to collect like terms. So we're going to do x plus x. So we have 2x. And then we're going to do 60 plus 75 plus 85 plus 70. So 60 plus 75 is 135. Well, I'm just going to do this. Why am I going to make my brain hurt, guys? Okay, so 10, 8, 16, 23, 29. Okay, good. There you go. So they add to 290. So I can write an equation. 2x add 290 must be equal to 360. So they want us to use algebra to find the size of this angle here. Great. If I know this angle, I can work out that exterior angle y, but I need to figure out what x is first. So I've formed an equation and I'm now going to solve it for x. So I'm aiming to isolate the variable x. So the first thing I'm going to do is I'm going to subtract 290 from the left hand side because that will eliminate my 290 there. Subtracting is the inverse of adding. But then when I do the same to the other side, 360 subtract 290 leaves me with 70. When we're solving, we're aiming to isolate the variable. So I'm aiming to get x on its own. So I want it to be x equals 2x is 2 multiplied by x. The inverse of multiplying by 2 would be to divide by 2. So 2x divided by 2 gives me x. 70 divided by 2 gives me 35. So x in this diagram has a value of 35 degrees. I can now use that information to find this angle here because this is the one that's got a relationship with the angle that I'm looking for. So x plus 70, well, when x is 35, 35 plus 70 is 105 degrees. So this angle numerically is 105 degrees. Now this is where we're going to use another angle fact. These two angles are related because they are on a straight line. Angles on a straight line they sum to 180 degrees. So if I do 180 subtract that 105, so y equals 180 subtract 105, which is 75 degrees. So I'm going to pop 75 degrees on my answer line.